The way we visualize data can change the decisions that we make. Examining the same dataset through different visualizations is not merely cosmetic, it can lead to very different conclusions, each telling a distinct story, sometimes with real consequences for how institutions respond. The visualizations we choose determine what patterns we notice, what risks we prioritize, and where resources get deployed. In analytics-driven fields like public safety, policy, and education, visualization is a decision-making tool, not a design choice. Choosing the wrong chart can obscure risk, while selecting the right one can make patterns immediately visible. I will discuss three visualization types: density maps, bar charts, and scatter plots that directly align with my interest in applying analytics to decision making. These examples come from guided coursework and independent analysis, and each visualization serves a distinct analytic purpose at different stages of analysis. Density maps are especially valuable in spatial decision making because they reveal concentration rather than individual points. I used this visualization to analyze rape incidents reported in Atlanta between 2023 and 2025. Unlike point maps, which can become cluttered and misleading in urban environments, density maps smooth the data to highlight hotspots where incidents cluster most intensely. By highlighting spatial concentration, density maps help identify areas that may require focused intervention or further investigation. One important analytic insight from this visualization is that interpretation matters. Several high-density clusters appear around hospitals, which represent reporting locations rather than assault sites. Without an analytic context, this could incorrectly suggest heightened risk at hospitals themselves. This distinction has real implications for decision making. Hospitals require victim services and forensic response resources, while true assault hotspots may require environmental prevention strategies or targeted patrol deployment. Density maps are powerful, but only when combined with domain knowledge. Bar charts are ideal for comparing values across discrete categories, which makes them especially useful in operational and administrative analytics. In this example, I used the previous dataset to examine the number of victims by patrol shift. The strength of a bar chart is its clarity. It enables analysts to immediately identify which shifts experience higher or lower incident counts without requiring advanced statistical interpretation. The inclusion of a reference line representing the overall mean provides additional context for determining which categories are above or below typical levels. In public safety and education analytics, this kind of visualization directly supports staffing and scheduling decisions. For example, shifts that consistently exceed the average may warrant changes in patrol deployment, training emphasis, or resource allocation. Bar charts are especially effective when decisions depend on categorical comparison rather than trend discovery. Scatter plots are most useful when the analytic goal is to explore relationships between quantitative variables rather than comparing totals or categories. In this example, I examined the relationships between average SAT scores and admission rates across Florida colleges in 2025. Each point represents a college, allowing patterns to emerge across the dataset. The fitted trend line helps summarize the overall relationship, showing that colleges with higher average SAT scores tend to have lower admission rates. Importantly, scatter plots support analytic reasoning without implying causation. While the visualization suggests an association between selectivity and SAT scores, it does not explain why the relationship exists or account for confounding factors. In practice, scatter plots support exploratory analysis by revealing possible relationships that can guide further investigation rather than serving as evidence of causation. Together, these three visualization types support different stages of analytic reasoning. Density maps help identify where issues concentrate, bar charts clarify categorical differences, and scatter plots explore relationships between variables. These are the visualization techniques I rely on most in analytics-driven public safety and policy work, as they strike a balance between clarity, interpretability, and decision relevance. Choosing the proper visualization ensures that insights are accurate and reliable. Ultimately, effective visualization aligns the chart with the analytical question, allowing the data to inform decisions meaningfully.